Good afternoon, class. Today we're going to be learning multiplying monomials.
Good job. Thank you.
6.1.
All right, so 6.1, we're going to split that up into 3 days. Okay, sometime we only do one section. We spend 1 day on it. We're going to spend 3 days on this one section. So we're going to go through it nice and slow. So first, I'm going to show you guys what a monomial is. Does anybody know what the word mono means? Like when you see it in front of something? One. Yep, mono, like if you see bi, like bicycle. Bi means two. Tri, like tricycle, three. Monomial, mono means one.
Is that why is it mono?
Maybe. All right, so on your reference sheet, this part you just need to read it. Okay. When we get to the part with the circle, I'll show you what to write down. So a monomial can be one of three things. It can be a constant. Constants are numbers. 2, 7.5, 13.5. It can be a number. It can be a letter. X, Y, A, Q. Okay, it can be a letter. Or it can be the product of a number and one or more variables. Okay, so let me show you some examples. That is a monomial, -7. Bless you. It's a constant. The second thing, that's a monomial because it's a variable. Look at the third thing. It's the product of two things, a 4 and an x cubed. That's the product of a number and a letter, 4x cubed. Okay. Notice what you don't have. Do you have any plus signs in there? No. Do you have anything like this, subtraction? No. There's no addition, there's no subtraction. That's the key that makes something a monomial. No addition, no subtraction. That's a D. All right. Here's another example. One or more variables. 2 times x times y. Do I have any addition there? No. Do I have any subtraction there? No. Then that's a monomial. As long as you don't have any addition or subtraction. Okay. Anyone think they could give me one more example of a monomial? Could be like the first one, the second one, or like the third or fourth one. Joe?
I said 4xy.
4xy. Yep, that'd be another one, like the 2xy. Yep.
Can you have multiplication in one?
Yep. So give me one with multiplication.
Like 4 times 2xy.
4 times 2xy. Yep. And normally we write 4 times 2 as 8. Perfect. 8xy. That's a monomial. No addition, no subtraction. Okay. So now, in that box where the circle is up at the top and you get the little symbol, there's an arrow that says what is the number that's up higher. Okay. That's an exponent. The number that we put down lower in the circle, that's called the base. So if I had something like x cubed, what's the exponent for x cubed?
Times 3? What? Wait, x. What do you mean?
What's the exponent in x cubed? The 3. The 3 is the exponent. And what's the base? The x. The exponent will always be a number. 3, 6, 5. The base, well, could be a letter, could be a number. Let's do this one. 2 to the 5th.
Do you want us to write these down?
Nope, you don't need to as long as you know which one is the base and the exponent. What's the exponent in this one? Yep, Josiah?
5.
5. What's the base? Yep.
2.
2. Any questions on how you tell what number is the base and which number is the exponent? Okay, easy enough. So, to multiply or divide monomials, okay, this is on your note sheet. The bases have to be the same. Yep, so there's a line right below it. And on that line, you put bases have to be the same. Okay, I'm not going to show you how to do it. I'm just going to show you a problem that you could do. X cubed times x to the 5th. That is a problem you can do. The base is x, the base is x. That's good. Same bases means you can do the problem. Here's a problem you can't do. X to the 4th times y to the 2nd. You can't do that. If I asked you what's the answer to that, you just read back the same thing. You can't do anything with it. What's the base right here on that one?
X.
And the base on the second one? Y. They're different. If you're going to combine them, once I teach you the rule to do it, they have to be the same. Okay. How about those? A cubed and a to the 4th.
Yeah.
Yep. They have the same base, but different exponents. Different exponents is okay. One's a 3, one's a 4, one's a 5, one's a 9. That doesn't matter. The numbers don't have to be the same at the top. It's the bases. Okay, so let's multiply these together and see what happens. Okay, what I'm going to do the first time is we're going to do it out. Okay, we're going to write it out kind of the long way, see the pattern, and then from now on, we're just going to go with the pattern. Okay, so we're never going to write it out the long way again. What does a to the 3rd power mean? Like if you had to explain that to somebody that says, you know what, I don't understand what a cubed means. I don't know.
A 3 times.
It means to do what with a 3
A
times?
multiply.
A times A.
It's 8 times.
Multiply by itself.
3 times. A times A times A. Okay? So we have A times A times A. Okay? This part, again, you can just watch this part. What about A to the 4th? What does that mean? A
times
times A times A times A. Okay, now let's look at what we have. A times A times A times A times A times A times A. How many times A's do we have?
6, 7,
7.
8. No.
1, 2, 3, 4, 5, 6, 7. So we have A times A 7 times. What's the short way of writing A times itself 7 times?
A x7 or A7.
A to the
A to the 7th power. Now, rather than doing it out the long way, does anybody see the arithmetic you could do with a 3 and a 4 to get a 7? And this is the shortcut.
Add.
Not multiply. We're going to get to multiply. You add.
Really not? Raise your hand.
You add. Okay, so we're gonna write this rule down. But when you want to multiply and they have the same base, all you have to do is add the 2 exponents together. Okay, so I think.
Are we done?
So
Oh no.
Only 4 hours.
let's write down to multiply powers. I think I'm just going to fast forward to that, and then we'll go back to the example. All right. Actually, you know what? I'll just write it down. Okay, so on the line where it says to multiply powers. Okay. You know what? If we don't come up, if that's not in the notes, I'll write it in. But I think we might get to it. So just where it says multiply powers, leave it for a second. If we don't get to it, I'll fill it in. And then to raise to a power, keep that blank for now. Let's do example 1a. All right. So, example 1a says r to the 7th times r.
Why just do it 2 bags?
Okay, tricky thing here a little bit. They didn't put an exponent on r.
So it's still 1.
If they ever don't put it, you put a 1.
So that would be. Is this all we're doing this week?
Yeah, it gets a little more complicated, but we're going to start with the basic ones and then with
Okay, so what do you mean by
R
this is
to
like
the
really?
8th power.
Wait, what do you mean by complicated? Are you doing like, let's say R 7 to the
Those are the
7th?
most
You'll see.
complicated.
Like, is it like you have like 2 sides on it? Like equal
Those
sides?
we're not going to have
I think
equations.
these are probably the most
That's so
complicated.
easy.
All right, so Fred, can you remind me, what's the shortcut? What do we do with the 1 and the 7?
Bro, we add them.
Leave him alone.
Do you remember, did you write it down, Fred? The shortcut right here that, what we did with the 3 and the 4? We add them. So Fred, in this case, what do you get with 7 plus 1 when you add them? So we get an 8. Now look at the base. The base started as an A. In the final answer, it was an A. So the base never changes. So what's my base going to be in this one for the final answer? Gemini? R. Okay, the base never changes. Again, we're going to write that down. If we don't get to it in the notes, we'll
Do
put
you have to
that.
write equals R8 or can you put R equals 8?
It's R to the 8th power. Yep. Just what I circled. All right, let's try 1b. C squared times D squared. You can't do it.
You can't do it.
So you just say, well, what does it simplify to?
I thought it was just
times DQ.
You can't do anything with it. How come?
Because
They don't have the same base.
The bases are different.
Two different numbers.
I like how we all yell it.
Those aren't numbers.
I meant to say letters.
How about,
Exponent?
no, how about x to the 4th, y to the 6th?
You can't do it.
You can't do it.
Bases.
Two different bases. One's x, one's y. What if I did this?
You still can't do
You
it.
still
Well,
can't.
now the exponents are the same though.
But the bases, but where it comes from, you can't.
The base is different.
The bases are different.
Where it comes
Okay.
from.
So when Mr. Roy or I ask you for the answer, don't write no solution. It's not that there's no solution. That's the solution. You just can't do anything. It's as simple as it already can be. All right. How about this one? A squared times A cubed. Keep the base the same. And then add the exponents.
Bet.
Okay, Noah. Be quiet, okay?
Joe's talking.
What?
I'm kidding.
Cody.
Where's the warnings? I call.
That's what my mom said.
Joe?
What? I'm sorry, Gemini said something
Okay.
funny.
All right,
You're
if you're
Gemini.
talking again, I'm going to put your name on the board, and that means you get written up.
Wait, why'd you just send out the name?
Yeah.
Because I'd rather keep people in here to learn if possible. If it gets to the point that I can't, then I will.
Alright, then.
Yeah, so
What's the one above it?
A squared times A cubed.
But what's the example?
That's A to the 5th. Oh, the example 1D.
These are easier. I like these.
Okay.
This is what you do.
How about
How many gel the content?
Savannah, M to the 4th times M to the 12th?
It's M to the 16th power.
M to the 16th.
This behavior
Yes.
has one E.
It should be at the bottom.
At the bottom, if you would look. Oh.
I pick up math lab.
Okay.
What added?
All right, so let's fill in that that line on the front where it says to multiply.
What one? Oh, no.
It says to multiply powers.
Sad.
That's
Why
nice.
does it look out?
That's nice
Oh, you know what? We're going to get to multiply powers in a second. Never mind. We'll fill that in. If you want to fill it in now, you can. But we're going to get to that.
Man, I used the lavatory.
Yeah, sign out. So this is the rule. To multiply powers with the same base, you add the exponents and keep the base the same. Okay, we're going to do a couple more examples like this. Okay, so after to multiply powers, put with the same base, add the exponents, keep the base the same. Okay, don't worry about the next one that says to raise a power. Don't worry about that yet. Okay, does everybody have this? So I can go back to example. We're going to go back a couple slides.
Can we go back to example 1 again?
1E?
Yeah.
Yep. All right, now, when I gave you guys the definition of a variable, of a monomial, okay, look what it says right here. It's the product of a constant and one or more. Okay, you can have more than one variable. This one only had one. This one had two. Let's look at another one that has more than one. Okay, let's look at this one. Okay. What's different here is the like terms are kind of spaced out. Okay. -3. Can anybody tell me something else here that looks like a -3? -3 is just a number, a 7. -3 and 7 are like terms. Can anybody tell me something else that looks like we have it in the first set and then again in the second set? Joe?
The C to the second and D to the third.
C to the second
I have a question though.
and
I
C.
I said D to the third because it's the same time.
C and C, same base. Can anybody tell me one more thing that we have that are kind of the same in the first and in the second? Madison?
D and D to the third.
D and D to the third.
I have a question.
Okay, so what you want to do is put the things that look the same next to each other. And that's what I'm going to show you next. Yep.
I was going to say, to get rid of the parentheses, can you just do -3 times the second then? Like, so multiply -3 to...
Excuse you, Xander.
I said excuse me.
Okay.
My mother taught me my manners.
So look at our numbers here. -3 and 7 are like terms. So I put -3 and 7 next to each other. C squared and C are like terms. So I put those two next to each other. D and D cubed are like terms. I put those next to each other. So now what we have is 3 little problems. Okay? Let's start with the first one. What's -3 times 7?
-21.
-21.
Are you
Now,
just watching here?
yeah, you can just watch this part. There's no exponent on the C.
So
You
It's
put
just
one.
a 1.
Put a 1.
C to third.
So C to the second
D to the third.
times C to the first is C to the
D to the
third.
fourth.
D to the 4.
D to the fourth.
What?
What?
Sorry, I was going to spell.
Wait a minute.
Wait, why are they all
So
together?
that's the equation?
How is that D to the fourth though? I thought we were multiplying.
That's a D to the first. That's 1D. And then D cubed is
I thought you were
another.
multiplying those things.
I go
No.
for DQ right now.
So Gemini, D to the first times D cubed is just like this one. R to the 7th times R. That's the exact same problem. You just add the two exponents together and keep the
I
base
thought
the
you were
same.
multiplying all of them though.
No.
Yes, we are.
You said to add.
I could put multiplication in there if you want like that. The rule though is you add the exponents when you multiply like bases. Right? Let's go back to this again. You add the exponents when you're multiplying like bases.
So you multiply with the same
Did you do multiply powers yet?
Doing it right now.
So basically,
Oh,
okay,
okay,
yeah,
yeah.
that makes sense.
Okay.
It
Took me about 10 minutes, but I get it.
So the shortcut is when you multiply with the same base, add the exponents. That's how you multiply. Add exponents. Yep. Yep. Okay.
Hold on, I'll give you.
Okay, guys, there's
I
too
know,
much
I went
talking
to the
again.
bathroom and I.
No, there's no, I know, he was talking, she said, no, there's no, I was in the bathroom and I need the notes, it's all online. You can go home and get it later. You don't have to get it right now. Or you can get it in study, or you can go to the library, or you can ask me and I'll print it
You have study.
if you have a study. All right, so example 2A. Let's fill in a few things that they didn't write. What's the exponent on y?
1.
Okay.
Then x, would it be negative?
What's the exponent on x?
Negative
1.
No, 1.
Negative
1.
I don't know.
What number is in front of x?
Negative
Negative.
X.
Negative 1.
Okay, they didn't put those in, but if you want to put them, you
Why
can
do you
put them.
have to put negative 1 there?
You don't have to. If I was doing the problem, I wouldn't even bother with that. But I think if I skip it, I'm going to confuse some people. So, what's the number in the first parenthesis? Just the number, no letter with it.
-5.
-5. What's the number in the second parenthesis? And this is where if I didn't put in the blue,
Negative 1.
I probably would have confused some people. The number in the second parenthesis is -1. Let's go to the next. X squared. Is there anything that's a like term with x squared?
X1.
Just x to the first. Now let's go to the y. Is there anything that's a like term with y?
Z3.
With y.
They both have a, what's it called?
No, that's it.
So we're looking for a y in the
Oh,
second
no.
base.
That'd be
But there
zero.
isn't.
There isn't. So there's nothing. We've done this, we've done that, the -1, the x,
Z3.
z to the third, and we're at the end. There's nothing else. So all we've done is we took these 1, 2, 3, 4, 5, 6. We had 6 things. We rearranged them so the like terms are next to each other. Now we do it out. What's -5 times -1? 5. X squared times x.
X. Oh, X to the third.
Keep the base the same. Add the exponents. Now, is there anything to combine with y?
No.
No.
There's a single y all by itself.
Just Y to the first. Oh, just Y.
And then
You
do
can put y to the first if you want, or just leave y.
Will you mark points down if you don't do it?
No. And then z,
To the third.
there's nothing to combine with that.
That's your answer.
That's how you write the final answer. And if you're like, well, I thought it was multiplying, that is multiplying. Whenever you put stuff right next to each other, it means
Can you
multiplying.
put the dots if you want?
You can put the dots if you want to. It means the same thing. Yeah. Right, let's try, you guys have a spot for 2B? Yeah. Let's try that one. All right, let's start with what's the number in the first set?
3.
3. Do I have a number in the second set?
Yes, 2. Negative 2.
-2. Okay. Now let's go to the A. I'm going to check them off as I do them. I did the 3 and the -2. A to the 5th. Do I have an A in the second one? Nope, then move on. B to the 4th. Do I have a B in the second one?
B to the third.
B to the 3rd.
And C to the eighth. Oh, and then you have C to the
I have a C, which someone already said, do you have to put the exponent of a 1? Nope. You have to remember it's there, but you don't have to write it.
Oh, the B to the fourth.
Anything with C? C to the 8th. All right. Now we'll go through. Those are like terms. Those are. And those are. What do you get when you combine the first two? Joe?
1.
Careful, you're multiplying.
Oh, sorry. Negative 5.
Negative 6.
Negative 6.
Wait, oh.
3 times negative 2. 8 to the 5th is just kind of hanging out. There's nothing next to it. Just write it down. Mallory, how about the B's?
B to the 7.
4 plus 3 gives me 7. And what about the C's?
C to the 9.
Right. You don't have to put the 1, but you better remember to write 1 plus 8 and put 9. And that's 2B. Okay. Any questions on that one? Okay. Just sign it. Okay. This I think everybody already has.
Wait, where is that? Where is that piece of paper?
That's on the front. Is there anybody that doesn't have that? Yes.
But you don't have that.
Hold on.
Okay. Does everybody have this? To multiply powers with the same base, add the exponents. Keep the base the same.
Hold on, I don't have the.
All right, now the next rule. Okay, we're basically gonna cover 3 or 4 basic rules, and that's what we're gonna use all week.
Excuse interruption.
Where's the way?
All right, so next rule. Okay. Let's say that you had something like a cubed, and you were raising it to the 4th power. Okay, this part, just watch this part. A cubed raised to the 4th power. That would look like this. A cubed raised to the 4th power.
So it's 8 times 8 cubed.
8 to the 12th power.
Not really.
We're gonna go through it. Just give me 1 second. So this is called a power to a power. Okay? Why? Because you have a power raised to another power.
My teacher last year gave me a different name.
It's a power to a power. Yeah, there's other names you can call it. What does that mean to do?
Times 4 by 8 to 8.
So write it like 4a to the 3rd.
No, 8. No. So you do 8 to the 3rd times 8 to the 3rd times 8 to the 3rd.
Yeah. Did people hear what Joe just said? A cubed to the 4th means to do a cubed times another one, times another one, times another one. You're multiplying a cubed by itself 4 times, but now look at that. That's the last rule we just had.
What is 9?
What's a cubed times a cubed times a cubed times a cubed?
3, 6, 9, 12.
What to the 12th power? A.
I'm a smart cook. What?
What do you mean?
That's a times a times a
Yeah.
times a times a times a times a times a times a
No.
times
wouldn't that
A,
be 3 times 3? Which
No.
is to
You're doing
the
8, so that's 3, 6, 9, 12, Joe.
You're at, remember you add
teacher last year.
You add.
You add
Top
the
rating is
exponents.
what I'm.
My teacher last year stopped us just that.
Okay. When you multiply this out using the rule we just did, you add them. 3, 6, 9, 12. Now, let's look at the shortcut so we don't have to do this every time. We got a 12 as the exponent. We started with a 3 and a 4.
You can multiply.
What can you do with 3 and 4 to get 12? Can you add them?
You multiply.
Multiply them. So here's another shortcut. We're never going to write this out again. From now on, when we have a power to a power, we're going to multiply.
Where do you raise this?
So you write this on the front.
Where do you raise this?
On the front, where it says to raise to a power, copy in what's underlined. To raise a power to a power, you multiply the exponents and keep the base the same. It's exactly what we did here. 3 times 4 is 12.
Raise the power to a power.
The base started as an A. In the final answer, it was an A. It did not change. Okay, so this is the second of a few basic rules that we're going to look at. Today, I think we're going to look at 3 of them. We've multiplied with the same base. We're doing a power to a power. The last one is going to be a product to a power. Okay, and they're all about the same difficulty. Okay, they're not too bad. You just got to keep them straight. Okay, does everybody have that?
Yeah.
You got it? All right, so now on the back, we're on example 3A.
This is a lot of work.
This is a power to a power. Power, another power. What do we do when we have power to a power? Multiply. So what do I get for an exponent?
You see 10. You see that
10.
C.
And what about the base?
C.
Keep it the same.
Yes.
C to the 10th.
I always use my recommended folder. I can hear it too.
Oh, yeah.
Okay, next one.
No,
Is
you're
this
always my recommended.
Y cubed to the 10th. Now, if I say y cubed, is that the same as saying y to the 3rd?
Yes.
It's the same thing.
It's just the proper term.
It's just there's a different name when you want to do this and this. You can say x to the 3rd, x to the 2nd, or you could say x cubed and x squared. Okay, it's just a special name for 2 and 3. Okay, so Xander, what would you get for this one?
Why did the
Y to the 30th. Okay, very easy, but you got to remember, wait, should I add 3 and 10 and write 13? Or should I multiply?
My hair.
Add would look like this. That's the kind of problem where you add.
But how come you have like multiply something right there?
You can put it or you don't have to put it. Either
Can you put a
way.
plus sign on?
You cannot put a plus sign. Nope. Okay, does everyone understand the difference between what's at the top and what's at the bottom?
Yes.
Add exponents, multiply exponents.
Yes.
Okay.
Are we using Mr. White's child?
Yeah, we should have a little time.
A little time?
Yeah,
We have like 40 chances.
enough time.
We're almost done.
Yay!
Let's do another page of notes and then try.
Wait, when will we?
Yeah.
All right, so last rule. Okay, it's example 4. Last rule is a product to a power. What makes something a product? What operation does product mean?
Addition.
Addition is sum.
What?
Multiplication. How do you pronounce what I just circled?
2x.
2x.
And it's 2 what x? Times. That's a product. So what we're going to look at in this example is taking a product, 2 times x, in parentheses, and raising it to a power. Okay, I'm going to show you how to do it. This is called a power of a product.
Your writing kind of sucks.
Yep, we're going to,
It's not on there.
you might have to add, yeah, we're going to have to add this. So what I would do, guys, is if you want to put all your rules together, if you have a little room between example 1 and the last line, you could write it in there. If you don't, you could just put an arrow and write it in on the bottom. If you don't have room on the bottom, you could write it in at the top of the next page. So just put it wherever you have a little bit of extra space. To raise a product to a power, raise each factor to the power. Again, not super complicated, but it's just another rule you want to put down. What I might even do on your reference sheet, I didn't put a spot for it, but in one of the empty boxes, maybe you want to put the 3 rules we did today in one of the empty boxes. If you don't want to, you don't have to. I'm not going to check it, but it might help you on the test. All right.
Oh, you mean on the reference sheet?
Yeah. So on the reference sheet, it looks like this on the back.
Yeah.
You might want to write down these 3 rules we learned today in one of the boxes. They're pretty big.
Are we gonna have one of them free or?
Yeah, you'll probably have one free.
You want to see my
Yep.
cover? No.
Okay, so let's look at 2x cubed. It says to raise a product to a power, raise each factor. Okay. Look at this. That's a factor. That's a factor. So to do this out, the first thing you're going to do is cube the 2. 2 cubed. The next thing you do is cube the x.
So we're writing this an example 4A.
We're going to do example 4a next. It's going to be another one like this.
So that example that you just did, what?
This one you can just watch.
Okay, but did it match to this rule?
Yes,
You
it
know what
did.
else in my head?
Yep.
Austin and Allie being something?
You, Savannah?
No, Austin.
Do you have a question? So to raise a product to a power, you raise each thing in the parentheses to that exponent.
So you multiply them?
No.
Just like this.
Not actually.
The 2, it's kind of like distributive property.
Yeah.
The 2 gets an exponent of 3, and the x gets an exponent of 3. Okay, they both get exponents of 3. Noah, so you're going to get written up? If I talk to you again, you have to leave, okay? Thanks.
Do you have an example for the to raise a power to a power?
Yep, we're
See
going to,
it?
well, power to a power, that was this.
What is that right up there?
Okay. Just leave it up for a second.
Example 3 is power to a power.
Oh, example 3.
Oh.
Yep.
Okay.
Example 4 is going to be product to a power. Product to a power is when you have parentheses and then an exponent outside. Okay, let's try another one together.
I have a question.
Oh, okay. This is an example.
This is example 4a. What's the first factor inside the parentheses?
-4.
-4.
-4c.
And what power is the -4 going to get raised to?
3.
That's going to get raised to the 3. What's the second factor inside the parentheses? C.
I see you 3bc.
And what power is that going to get raised to?
The 3.
The 3. Now, this one's not done because that's a number to a power. We can use our calculator and do it. Okay. What symbol do I have around the -4? Parentheses.
Parentheses.
When you type it in on your calculator, you have to type it with parentheses.
How do you do
Don't
it?
the
How do you do
parentheses
the
just mean multiply?
It's important you put the negative inside the
It's
parentheses.
112.
Did I miss?
What?
I just
What button on the
multiplied
computer?
3 by -4.
It's 112. No?
That's literally.
No,
It's
no.
4 times 3 times 3.
With 4 plus 16.
It's not 4 times 3.
It's
It's
4
-4
times
times -4 times -4,
Yeah.
which is -64.
What? I thought it was to the 4th. Okay, never mind. I thought it was to the 4th power.
Take off your hood. Disrespect.
Yeah.
Okay, let me show you what happens if you don't put parentheses. Let's do something squared. Okay, something we know. What's -5 to the second power?
Negative 10.
-5 times -5.
Oh, no.
11.5.
-64.
It should be 25. Now, watch what happens if you do this. No parentheses. Wrong answer.
That.
Okay?
Whoa.
If you don't put parentheses, the calculator is only going to square the number, not the negative.
Wait, I still don't understand how you got negative.
We're squaring the whole thing. Will, we just typed that into a calculator and wrote down what it gave us.
Okay,
That's
can you
it.
go back to the calculator because,
Yep.
so the difference,
One becomes a negative one.
I know, but I'm trying to see how that happens.
Because it's not parentheses.
Why that happens? Think about if you do something to an even power. Negative times negative.
Yeah, that's a positive.
That's a positive. Now let's say you had a negative number to the fourth power. It would be negative times negative times negative times negative.
Negative times negative times negative.
So
negative
equal
times
positive.
negative.
It's a positive.
So the odd.
Anytime you have an even power, all the negatives cancel. But let's try an odd power. Let's say you had a negative times a negative times a negative. What's a negative times a negative?
Positive.
So a negative times negative is a positive,
Positive times negative is negative.
and a positive times a negative is a negative. So the pattern, what ends up happening, is if you raise a number to an odd power that's like a negative number to an odd power, it always comes out negative. If you raise a negative number to an even power, it comes out positive. Now, you don't have to remember that as long as you type it in on the calculator correctly.
Okay, I was just trying to think of it as if I did it in my head.
So if you raise it to an even power, it's positive. If you raise a negative number to an odd power, it's negative.
Okay.
Again, though, I'm not going to write that rule down because you already have enough rules to remember. I just want you to use the calculator to do that. Okay? I could write it down, but again, it's just more stuff to remember. Yep.
So basically what you do is to get negative 64, you just times negative 4 times negative 3 times.
Yes. Negative 4 times negative 4 times negative 4.
How many shirts do you have to?
I'm not ready to stop.
All right, let's try this one. Will, what's missing? It's hidden inside the parentheses. We should actually two things that are hidden.
I just heard a phone bill.
It's not something we learned today. It's something we learned all year.
Oh,
Yo.
Well, one of them we might have learned today, but I think some people already knew it. What exponent is on this x, even though it's not there?
oh, 1.
1. What number is in front of that x, even though it's not there?
1.
Negative 1. So inside the parentheses, there's three things. Negative 1, x, and y squared.
Don't you do them all the same?
So we have to raise each one of them.
Raise like Jesus.
Back from there.
Each one of those is going to get raised to which power? To the fourth. The negative 1.
You never seen that line?
Hey, Savannah, I need you to play now. It's like the third or fourth time I've asked you. All right, so the negative 1 gets raised to the fourth. What about the x? What power does that get raised to?
I think
Everything gets raised to the 4th.
Everything gets raised to the fourth. Y squared gets raised to the fourth. Now look what's going to happen here. We just did this in example 3.
You add 2 and 4 together.
Let's see if we can do negative 1 to the fourth without a calculator. What's
times 1.
negative 1 times negative 1?
Negative
1. Again?
1.
Positive 1.
What's that times by negative 1 again?
Negative 1.
And then times by negative 1 again.
Positive 1.
Positive 1.
What?
Yeah.
Negative 1 times negative
Just
1.
make it like times you get
Stand
times
out,
negative
like-
1 by itself.
Oh, okay.
Yep.
Savannah, I was the one talking.
That's okay. I know.
That's 3
It's
weeks.
okay.
I know.
X to the first to the fourth. What do you do when you have a power to a power with these two numbers?
Don't you add it, I think.
Multiply, right?
Multiply. What's 1 times 4?
4.
So x to the 4th.
Do it again.
Y to the 6. 8.
What's 2
Y to
times
the 8th.
4?
8.
Y to the 8th.
Oh, I'm so glad you clarified that because I would have literally added the exponent.
No, we don't add here. That a power to a power, you multiply.
Yeah.
Okay. Any question on that one?
Can you multiply for a product to a power 2, right?
Savannah, you're talking again. What do you need? Okay. Why do you have to say that?
I know.
I hope you're writing it down. You don't have to tell me. Okay.
We multiply for a product to a power, right?
You always multiply when you have something like this.
Okay.
Like that would be x to the 6th.
Mm-hmm.
If you were adding, that looks more like this. That's x to the 5th.
Okay.
Okay?
So when you have parentheses, basically always multiply.
Yep. All right, so you've got 4. Yeah, we got spots for these. Right. Let's do this one together, and then we'll let you guys try the last one. How many factors inside the parentheses?
3.
3. What's the first one?
3.
3. The second one?
C2.
C squared.
Yeah. C1.
Third one?
C.
D to the first.
D.
D. If you want to put to the first, you can do that too. Each one of those is going to get raised to which power?
5th.
5th. 3 to the 5th.
15 to
What about c squared? What power?
That would be to the 10th.
Well, eventually, but right now we're just going to raise it to the 5th. D to the first,
5th.
To the 5th,
the
yeah.
5th.
Oh,
Now, 3 to the 5th, we can use our calculator.
15.
3. Remember, not 3 times 5.
Oh.
3 times 3 times 3. times
45.
3 times 3.
Oh, wait. It was 3 times 3. I was thinking 3 times 3.
243.
It'll fit off there.
Just a little bit.
Now, if it starts to get too big, we're not going to do it up. Okay, if it gets to like 3 to the 20th, we're just going to leave it. But 3 to the 5th, it's only in the hundreds, so we'll do it out.
So we're doing.
Wait, why do you have 243?
That's 3 times 3 times 3 times 3 times 3.
Okay.
I just did it out on calculator.
It's a long enough of it.
How about c squared to the 5th?
C to the 10th.
C to the 10th. Okay. Some people, what they do right away is they just put all the ones here, and then they just think of it as, oh, 5 times 1 is 5. 5 times 2 is,
That's easier
10?
to space.
and then 5 times 1 is,
5.
so d to the 5th.
A weird, so it sounds like we're dropping.
Wait, why is my
You can make
What's the name of
this? Starts with exponents.
Wait, so what do I have in the parent?
Mhm.
Alright.
That's my move.
Surprised that's the first one I've had on here.
Okay, I can be shamed.
Will, you get to join the club of people that are talking.
That's cool.
Again.
Why haven't you put my name down on the board yet?
You don't understand because
I think you just don't want.
Do you want me to put your name?
Oh.
Okay, I will.
I didn't talk about it.
Any questions on that one?
No.
Okay. So, last one.
can you do this one with
How
us?
many demerits?
That's scary.
Now,
Yeah, this one looks different.
it looks a little different, right?
How many demerits do you need to get a...
Do it as 2 separate problems. Pretend that the problem on the left, that one's just like we did up above.
She's saying it's easier to
The problem on the right, do that one separate. So do on this 2 separate problems, and then we'll come back together and write the final answer. Okay, if you don't have a calculator, that's fine. Just take a couple seconds and write it down.
Sorry.
Let's take a look at the left side first. What exponent is on the -4? Yep, 1. What exponent is on the x? Yep, 1. So let's fill those in. So now we have -4. Multiply. What's 3 times 1?
3.
3. Now do it again.
3.
what's 3 times 1? 3.
3.
That's what you should get for the left.
Yeah.
Now let's go to the right.
Oh,
What exponent is on the 5?
wait, that's for the left?
Yep.
Oh,
We're not done yet, but that's the first part. Now on the right, 5 has an exponent of 1. Do it out.
So wouldn't it be 5?
5 to the 1 times 2,
Yeah,
which is
5 to the 10. Right?
5 to the
5 to the second.
Yeah, it's 5 times 5.
Now, x to the
Or second.
3 times 2.
6. I think something's wrong with me today. I was gonna say 10.
Now, we did this earlier. What was negative 4 cubed?
Negative 64.
Negative 64. X to the third. What's 5 to the second power?
25.
25.
X6.
X to the sixth. Look at what I have right here. This,
Oh, I didn't do that. I didn't multiply the negative 64 and 25.
So much.
this is exactly like this. You have x's, y's, and numbers. Let's put the like terms next to each other.
Do we have to?
No.
Because that's a big number. So could I have just left it as negative 64, x to the third, 25, x to the sixth?
Yeah, that's pretty big, so we'll just combine what we can.
Okay.
So what can negative 64 be combined with? What's the other like term, like factor there?
25.
25. So if we were going to actually do that out, we'd need our calculator. That's why I said I couldn't do it in my head.
Or we can just multiply.
We just have to multiply those out.
Where'd
We're
you get
not
25 from?
5 to the second power.
Oh, so
So we're not going to multiply negative 64 times 25. That's too big. Okay, we'll just leave it. X cubed. Is there any like term that I can put that next to?
Yes, x to the sixth.
X to the sixth. Now the first part, we're just going to leave it. Don't worry about doing it. X cubed times x to the sixth. What do you do with the 3 and the 6?
just add.
We multiply them
No, add the
there's
others.
friends.
Is this a power to a power?
Oh, no, it's not. So you
It's
have to
not.
add.
You have to add them.
X to the 9. And you don't put those in parentheses?
You don't have to put the x to the 9th in parentheses. You can, you don't have to. You can put the dot, you don't have to. Means the same thing. Okay, so couple quick reminders before I give you the homework. One, I've given you some suggestions of problems I would put on the reference sheet. If you want to put these, great. If you don't, don't. I don't care. It's up to you. But
Wait, I already did those.
these are similar to what's on the test. So remember, that sheet is the only sheet you can use on the test.
Are those the same ones you gave us before class?
These are different. These are from today.
Oh,
These are
okay.
today.
Wait, can I write those down?
Yeah?
Disgusting.
Okay. Test on Friday. This is our second test of 3. We've got one more test after this. Double shop week, we've already mentioned that over the next couple weeks. Okay, so after this week, you come back May 21st.
We better do that on this test.